For this video, I want to cover how to use the integration tool to find the area under a peak. That's going to be this red candy cane looking triangle over here. So if I want to find the area of a peak, you might want to do this if you're calculating concentrations. First, I'm going to zoom into the peak that I want to calculate. This peak right here seems to be a good candidate for calculating area because it's only one peak, one chemical, so the mass fragments down here are the same on the left-hand side and the right-hand side of the peak. So to get its area, simply drag the candy cane, drop it on the peak, make sure that your scan selector is not at the same point in time, hover your cursor above the area tool, click, and then drag upwards. You see these two red filled in triangles that pop out? Place them at the beginning of where you want to start counting, and then the end of where that peak sort of dies out. To see the area under the peak or the integration, you can right click and say show integration. Two different numbers pop up. One says R1 area. That's just the entire area from the starting red triangle to the ending red triangle. Whereas R1 area minus base tries to estimate the baseline noise that's coming through and then subtract it out. For this, we've got really great signal to noise, so the numbers are about the same, 30 million on each. But if I had more noise, you'd want to be more careful where you place these. And be careful not to bring your area tool inward to where the peak has already started, because then it assumes the starting of the noise is this intersection point where you can see that red line going up. So it cuts off a whole bunch of the area you want to calculate. For instance, we were at 30 million a second ago. Now just moving it in that little bit is now saying it's only 24 or so million. So that's the area tool. Thanks.